September 5th, 1977. A rocket rises from Cape Canaveral. Inside its payload bay sits a machine, 1,590 pounds of metal, circuits, and a golden record. A message in a bottle, thrown into an infinite ocean. Today, nearly 5 decades later, that machine is still traveling, over 15 billion miles from home. The most distant object humanity has ever created. Its name is Voyager 1, and this is the story of where it is going. Voyager 1 is dying, slowly, quietly, from energy starvation. The spacecraft runs on 3 small nuclear generators, plutonium-238 spheres, radioactive hearts that have been beating for almost 50 years. But physics is unforgiving. Every year, NASA loses 4 watts of power. Engineers have performed desperate triage. Heaters shut down. Instruments shut down. Systems, one by one, gone. By 2030, maybe 2036, the power will drop below the minimum needed to transmit. Temperatures will plummet to minus 459 degrees Fahrenheit, near absolute zero, the coldest anything can be. Earth's radio telescopes will receive one final whisper, a faint signal from 15 billion miles away. And then, silence. Permanent. Total. Voyager becomes a ghost ship, a frozen relic hurtling through the void, carrying humanity's message to no one. Most people believe Voyager 1 has already escaped the solar system. They are wrong. Yes, in August 2012, Voyager crossed the heliopause, the boundary where the sun's influence ends. Headlines celebrated around the world. But crossing the heliopause is not leaving the solar system. The true boundary is the Oort cloud, a massive spherical shell of ice and rock, extending nearly 1 light year, 6 trillion miles from the sun. Voyager travels at 38,000 miles per hour, 10.5 miles per second. And yet, it will take 300 years just to reach the inner edge of the Oort cloud, 30,000 years to pass through entirely. Think about that. 30,000 years ago, humans were painting animals on cave walls. We had not invented agriculture. We had not built cities. We had not written a single word. When Voyager finally leaves our solar system, human civilization will be unrecognizable or extinct. Over the next 300 years, Voyager drifts through the local interstellar cloud, a region of elevated hydrogen and helium, the space between stars. By 2100, 16.5 billion miles. By 2200, 22 billion miles. By 2300, 27 billion miles. Light from Earth will take over 1.5 days to reach Voyager's position. A message sent will not arrive for 36 hours, but there will be no one listening. The probe remains structurally intact. Space is a near-perfect vacuum. No air to slow it, no weather to erode it, no oxygen to rust it. Scientists estimate Voyager could drift undamaged for millions of years before encountering anything substantial. In approximately 40,000 years, around the year 42,025 AD, Voyager 1 makes its first close approach to another star, Gliese 445, a small, dim red dwarf. In the constellation Camelopardalis, Voyager will pass within 1.6 light years, 9.4 trillion miles. This is not close by stellar standards. 1.6 light years equals 100,000 times the Earth-Sun distance. Voyager will not orbit. It will not stop. It will simply glide past. an ancient artifact from a long-extinct civilization, passing silently through someone else's stellar neighborhood. By this point, 40 millennia will have elapsed. Human civilization could have risen and fallen dozens of times. We might have colonized the galaxy, or vanished entirely. Yet, Voyager continues, following the exact trajectory calculated by engineers in 1977, completely indifferent to whatever happened to its creators. Fast forward 200,000 years. Voyager has traveled 3 light years, 17.6 trillion miles, a distance comparable to Proxima Centauri, yet nowhere near any particular star. The Milky Way is vast. Stars are separated by light years of empty cosmic desert. Voyager drifts through this void, utterly alone, a silent monument to a species that might not exist anymore. By 296,000 years, Voyager passes within 4.3 light years, 25 trillion miles of Sirius, the brightest star visible from Earth's night sky. At this timescale, continents on Earth will have shifted dramatically. Ice ages will have come and gone multiple times. Mountain ranges will have eroded completely. Entire species will have evolved and gone extinct. Yet, Voyager's course remains precisely as calculated, the exact trajectory determined by slide rules and early computers in the 1970s. At the 1 million year mark, Voyager has traveled 15 light years, 88 trillion miles, deep into the galactic neighborhood. The probe remains structurally intact. Metals do not decay in vacuum. Circuits do not corrode without oxygen. Even the golden record remains playable. Sounds and images of Earth from 1977. Thunder, whales, Beethoven, greetings in 55 languages. A child's voice saying hello. But there is no one to play it, just an eternal archive, drifting through the void. By 10 million years, the distance reaches 150 light years, 880 trillion miles. At this timescale, something strange happens. Stars do not remain fixed. They all orbit the galactic center at different speeds. Our sun completes one orbit every 225 to 250 million years. Voyager's trajectory will appear to curve, not because it changes direction. It has no propulsion, but because the entire universe moves around it. Voyager maintains its straight line path, while galaxies spiral, while stars are born and die, while everything else changes. Jump forward to 1 billion years. Voyager has traveled 1,500 light years, 8.8 quadrillion miles. At this incomprehensible timescale, the galaxy itself has changed. Many stars visible from Earth in 1977 will have exhausted their fuel and died. New stars will have formed from collapsing gas clouds. Entire stellar generations will have been born and extinguished. Yet, Voyager continues, unchanged. It is now older than most stars it passes. Our sun itself faces mortality. In approximately 5 billion years, the sun will exhaust its hydrogen fuel. It will swell into a red giant, consuming Mercury, consuming Venus, possibly consuming Earth. Then, it will collapse into a white dwarf, a cooling ember, where life once orbited. By this point, Voyager will be 7,500 light years, 44 quadrillion miles from where the sun once was. It will be completely oblivious to its creator star's death. No signal received, no gravitational change felt. It will simply continue, carrying evidence that Earth and humanity once existed, long after both have been incinerated. Even more staggering, in approximately 4 billion years, the Milky Way will collide with the Andromeda Galaxy. This cosmic merger will take hundreds of millions of years, gravitationally rearranging billions of stars, two galaxies becoming one. But Voyager will survive, unscathed. Despite billions of stars involved, the distances between them are so vast that direct collisions are extremely rare. Voyager will drift through this galactic collision, like a grain of sand passing through two clouds of dust, untouched, continuing its journey through whatever new structure emerges from the merger. The cosmos itself has a timeline. Current models suggest the universe will continue expanding forever. Eventually, all stars will exhaust their fuel. Galaxies will drift apart. In trillions of years, the universe enters what physicists call the degenerate era. Only dead stellar remnants remain: white dwarfs, neutron stars, black holes. No new stars form. The cosmos goes dark. Even in this dying universe, Voyager persists. Structurally, it could survive for quadrillions of years or longer. Eventually, over unfathomable timescales, 10 to the power of 30 years. Even the probe's atoms might decay through quantum processes. Or it could fall into a black hole, or be torn apart by tidal forces near a neutron star. But these events are so far in the future, billions of times longer than the current age of the universe, that they become purely theoretical. For all practical purposes, Voyager 1 is eternal. What is truly haunting is this: Voyager 1 will likely outlast all evidence of human civilization on Earth. Wind, water, and geological processes will erase our cities, our monuments, our artifacts within a few 100,000 years. Continental drift will destroy even our deepest structures. Earth itself will be consumed when the sun dies, in 5 billion years. But Voyager, frozen and silent, will continue carrying the golden record through the void. The last remaining proof that humanity existed. A message in a bottle that will never be found, drifting forever through an increasingly empty cosmos. So, how far will Voyager 1 actually travel before it stops? The answer is, it never stops. It is moving at 10.5 miles per second, and there is nothing in the vacuum of space to slow it down. No air resistance, no friction, no forces acting on it. Voyager 1 will continue traveling essentially forever, accumulating distance infinitely. In 40,000 years, it passes Gliese 445. In 300,000 years, it drifts past Sirius. In millions of years, it wanders the galactic neighborhood. In billions of years, it outlives the sun itself. In trillions of years, it drifts through a dead universe. The distances become meaningless, the timescales incomprehensible. At some point, we are not even discussing a spacecraft anymore. We are discussing a cosmic monument, a tombstone for humanity, carved not in stone, but in velocity and trajectory, continuing endlessly through space, long after everything that made it, everything that knew about it, everything it was built to study, has vanished into entropy. That is the true answer to how far Voyager will travel. Not a distance, but a duration. Forever. Voyager 1's journey is eternal, a testament to human curiosity drifting through the cosmos long after we are gone. But Voyager 1 was not alone. It had a twin. Watch how far will Voyager 2 travel before it stops forever to discover the other half of this infinite odyssey.